Hello. At this station, we're going to test the quality of the water of the Nooksack River to determine how healthy it is for the 5 species of salmon that live in the Nooksack River. Earlier in the habitat assessment, you made some observations of the Nooksack River in the riparian zone to see how that affects the health of the water and the livelihood of the salmon, from impacts such as roads and buildings to moving water. Today, we're going to test some specifics of the water to determine if it has the 3 C's for salmon. Do you remember what those 3 C's are? That's right, it's cold, clean, and clear. We're going to test those today by doing some experiments and writing down our results so that we can examine those over time and share them with other scientists. Let's start by testing how cold the water of the Nooksack River is. We're going to use a tool that you may have used to test your temperature. Can you think of what that tool is? You may have guessed it, it's a thermometer. Salmon prefer water temperature that is 5 to 13 degrees Celsius, but can tolerate temperatures up to 20 degrees Celsius. They're not like us in that they can take off a layer or put on a coat. They rely on the water temperature for their survival. All we need to do for this test is wait for our thermometers to adjust to the temperature of the water and record the result. Now that our thermometers have adjusted to the water temperature, let's take a look. If you look at our thermometer here, it looks like it's above 15 degrees, but below 20 degrees. I would call that about 18 degrees Celsius. Let's double check with our other thermometer here, just to make sure they're both accurate. And again, it looks to be right around 18 degrees Celsius. Knowing that we have a temperature of 18 degrees Celsius, take some time to think if that is excellent, fair, or poor for salmon. I think that a temperature rating of 18 degrees Celsius is a fair rating. Earlier we said that salmon can tolerate temperatures up to 20 degrees Celsius, but they prefer temperatures that are 5 to 13 degrees Celsius. So a measurement of 18 degrees would give us a fair rating. The next test is called a turbidity test. Turbidity is a measure of how clear the water is. If you were a salmon, which of these samples would you like to live in? Would you prefer low turbidity, medium turbidity, or high turbidity? If I was a salmon, I would prefer to live in clear water or low turbidity. It'd be easier for me to find my food, and I could avoid predators that are trying to eat me. But how do we actually measure how much dirt is in the water? We do that using a turbidity tube. A turbidity tube has numbers on the side of it. These numbers correspond with measurements called NTUs. Salmon prefer to live in water that is below 10 NTUs, but can survive in water that is below 30 NTUs. So take a look in the top of this tube and see if you can spot the shape that is at the bottom. It looks like we can't see it when the tube is full because the water is cloudy. So we have to let some of the water out. Let's see how much we need to let out until we see the symbol. The water is at 25 NTUs on our turbidity scale. Take some time to determine if you think that is excellent, fair, or poor for water clarity for the 5 species of Pacific salmon in the Nooksack River. I think that that number is fair. Salmon can tolerate anything below 30, but prefer anything that is below 10. So a reading of 25 NTUs would give us a fair rating for turbidity. Our third experiment today is going to test the amount of dissolved oxygen that is in the water of the Nooksack River. Salmon use oxygen that is mixed into the water. This happens when the water is moving, like in a current. It also happens on a windy day to churn in the oxygen from the air into the water. What do salmon use to breathe underwater? You may have guessed it, they use their gills to breathe underwater. Salmon can tolerate dissolved oxygen that is at least 6 parts per million, but prefer to have at least 9 parts per million of dissolved oxygen. And parts per million can be seen as a fraction, where you have 1 million parts of water, and we're measuring how many parts of those are dissolved oxygen. Or to look at it in another way, if you imagine that I have 1 million red Skittles and I take 10 red Skittles out and put 10 purple Skittles in, I now have 10 parts per million of purple Skittles. Parts per million is a way to measure things that are really small, like oxygen that is dissolved in the water. To measure the amount of dissolved oxygen, we need to do a scientific experiment. So I'm going to put my safety gear on and we'll get ready to test our dissolved oxygen. First, we collected our sample. Next, we'll add 2 chemicals. We call them chemical 1 and chemical 2. But their real names are manganese sulfate and lithium hydroxide monohydrate. The sulfates in chemical 1 will clean the sample, while chemical 2 changes the color to show us that there's oxygen in there. So now that we've added those chemicals, it's time to shake it. Whoa, check that out. To me, it looks like we just made orange juice with a lot of pulp in it. I don't think it will taste very good though. Let's let all of that pulp settle. Now we can add our next chemical. Can you guess what we call it? You may have figured it out. It's chemical 3. This one is also known as sulfamic acid. This will get our sample's oxygen ready to be measured and will change the appearance again. Let's shake it up and take a look. Whoa, check that out. It definitely changed. To me, it looks like we turned our pulpy orange juice into apple juice. I still don't think it'll taste very good though. Now we need to collect 1 million parts of water, which we'll actually do with this small container. There we go, 1 million parts of water. The last step in this experiment is called a titration and involves our last chemical. Can you guess what this one is? Well, I may have fooled you this time because we call this one sodium thiosulfate, which is what its actual name is. I'm going to add 1 drop of this sodium thiosulfate at a time and stir our sample after each one. Your job is to decide how many drops it takes for our sample to turn clear. That number will be how many parts per million of dissolved oxygen are present. So we're at 6, which is the minimum for salmon to survive. And it's definitely changed, it's getting lighter. There's 9 drops. Let's see if 1 more will change it clear. That looks pretty clear to me. So we will call that 10 drops or 10 parts per million of dissolved oxygen. And while I record that, take some time to decide if you think that is excellent, fair, or poor for salmon. I think that a measurement of 10 parts per million is excellent for dissolved oxygen. Anything that is over 9 is an excellent rating. Now let's take all 3 of our results and put them together to generate a conclusion. For temperature, we had a rating of fair. For turbidity, we also had a rating of fair. And for dissolved oxygen, we had a rating of excellent. So take some time to think about an overall conclusion on what the water quality told us about the health of the Nooksack River for Pacific salmon. Do you think that it is excellent, fair, or poor? I think that based on our 3 results, we have a rating of fair. Most of our results generated a fair rating with 1 excellent rating. So I think that overall, the water quality of the Nooksack River is fair for salmon. Thanks for joining me at the Water Quality Station and have a great rest of your virtual field trip. Bye, 4th graders.